Well, good morning. People here this morning to hear about IIS and what we're doing in the next version. I always like to start off just by getting an idea of what experience people have in the room. How many people here are running IIS in production? Great. How many people are running IIS 8? A few? IIS 7 or 7.5? It's a good number. Anybody still running 6? Quite a few people running IIS 6 as well. So this morning what I'd like to talk about is what we've done since IIS 8, which released late last year. By way of introduction, my name is Wade Hilmo. I am a Principal Development Lead on the IIS project. I've been with Microsoft for just over 20 years, since 1992. I've been on the IIS team since 1997. So I've been there kind of a long time now. Before I start talking about IIS 8.5 specifically, which is the version we're going to release, I want to talk about what's happened since we released IIS 8. Or since we've released IIS 7.5. The IIS team used to be a fairly large team, and IIS 7 and 7.5 were big releases for us. We've shifted our focus so that we're looking at cloud as well as IIS, and really around the time IIS 8 shipped and around the time we've been working on IIS 8.5, we've been looking at how to use our resources on the team to kind of develop the public cloud, the private cloud, and see how IIS fits in. To that end, we have 3 product offerings. The blue one on the screen, Windows Azure Websites, is our public cloud offering. We have a new one, which is, I believe, just releasing today. I think I saw a piece of email. They're having a celebration back at the office. It's labeled here, Websites for Windows Server. For hosted and private cloud. I think they've actually changed the name to Windows Azure Pack. And what that will allow you to do is take the same Windows Azure Websites offering that we've been hosting for a while and bring that to your own data center, either for private cloud, or if you wanted to host, do business as a hosting provider, you could use that same setup we do. Both of these products are built on top of IIS itself. And so everywhere you see a web offering from Microsoft, IIS is kind of sitting at the foundation of it. We spent a lot of time trying to figure out how IIS fits in. We have 2 different, life on the product team, we have 2 kind of different development cycles. IIS ships with Windows, and as such, we release once every 12 to 18 months, about the same time schedule that Windows does. My counterparts working on the other pieces of this circle here, they release about every 6 weeks. And so we kind of have to work together to plan how we're going to be able to push features into IIS that they can take advantage of. And that's what I'm going to talk about here this morning. So what's new in IIS 8.5? This has not been a huge feature release for us. When we brought out IIS 7 in particular, it was a huge feature release with a lot of new stuff. IIS 8 kind of built along the scalability theme. We brought in certificate scalability. We brought in the ability to scale to very large computers with NUMA architecture. In 8.5, we're continuing that theme. Most of the work we put in has been being able to add more sites to the box and have a very large-scale server. This helps us in the cloud offerings to be able to host many sites. We also had an opportunity to do some new logging features. So when I talk this morning, there'll be kind of a break in the middle. We'll talk about scalability, and then we'll switch over to talk about what we've done with logging. In brief, the features that we have are dynamic site activation, idle worker process page out, some logging enhancements, and then some ETW logging, which allows you to collect real-time log data, which is pretty interesting. I want to talk first about dynamic site activation. This is a feature that has a fairly small footprint. You don't see really anything in the configuration. All of it happens behind the scenes. But it's taken most of the resources of my team to do this. There's some fairly major internal changes that I'll talk about to make this happen. So what do you have to do to get lots of sites to run on a web server? When I think about this question, what I'd like to be able to say is it depends on what those websites are doing, and the workload of the websites should drive how many you can have. When we talk to customers that are providing hosting services, that's not the answer we get. What we find out when we talk to hosting providers is that we are configuration bound. They're limited in the number of sites they can put on a single IIS server because the configuration system itself limits that. I want to talk a little bit about why that is and what we're doing to address it. The first thing to know is that there's two general ways that we could do configuration, and IIS has done both historically. Early versions of IIS up through version 6 had the configuration as a service. This is the metabase, which anybody running IIS 6 is certainly familiar with. The metabase provided a single instance of the configuration that the entire server, the configuration tools, the process management tools, and the worker processes could use. One copy of the configuration was fairly efficient in that way, but it had some other limitations. One limitation was anything that interrupted the configuration service could take out an entire server. What we did in IIS 7, we changed our philosophy, so instead of having a centralized configuration, every component of the system has its own copy of configuration. And so the worker process activation service has its own copy. Each individual worker process that's handling requests has its own copy, so they can't interfere with each other. What that does, though, is it does introduce some scalability limitations. When we designed the new configuration, starting with IIS 7, we were very interested in performance. And performance in the context of a web server is how many requests you can push through how fast. This is a different topic than scalability. Scalability says how many different worker processes can be using the configuration at the same time. And so what we found is that the worker processes scale fairly well with their own small copy of the configuration, but our tools, the worker process activation service, which we call WAS, and also iNet Manager, our user interface, they load the entire configuration for the whole server. So if you have a huge number of sites, you'll see those processes taking up a very large amount of memory. And that's something we wanted to address. And so in IIS 8.5, we looked at reworking the configuration. And what we did is we made a special configuration provider that talks to both of those services, the WAS service and also the UI, iNet Manager, to be able to offer optimized access to the data so that it can load a much smaller piece of data. The second thing I want to talk about is bindings and worker processes. If you've been working with IIS for a while, you certainly know about application pools and worker processes. With the worker processes, one of the ways we allow you to get good, efficient use of the machine resources is we don't start a worker process until it's needed to handle a request. We call that demand starting. Each of those application pools not only has a worker process associated with it, it also has a counterpart piece of data in kernel mode called a binding. We don't talk much about bindings. In particular, we don't talk about URL registrations and queues. These are concepts that are inside of HTTP sys. But what we've done in the past, up through IIS 8, is if you set up a site with 5,000, or a server with 5,000 sites, when you do net start W3SVC or start IIS, we pre-configure all 5,000 of those sites in kernel mode. That takes time to do. That also takes memory in kernel mode. So what we've done in IIS 8 is we've, again, taken a scalability approach, and we now register those bindings and set up those kernel mode queues only as needed, and we demand start them when we demand start the worker process. In this way, we can get scalability. Now, one of the things that we're seeing in both the configuration and the bindings is that the scalable code is a little bit slower than the traditional code that we've had. And so instead of just changing the way IIS works completely, we have a threshold. And if you have a smaller number of sites, we do it the same way it's always worked. If you have a larger number of sites, we switch into this new mode and start taking advantage of the scalability. By default, out of the box, it's 100 sites. Data that we get collecting data from customers suggests to us that there's a very small number of customers running 100 sites or more, and that the ones who are running 100 sites are typically running a much larger number than that. Just a refresher on the IIS design. HTTP sys sits down in kernel mode. We have a queue for each worker process, which we generally don't talk too much about, but it's there. We have WAS, which is the worker process activation service, and then we can demand start worker processes as needed. So if a request comes in, HTTP sys determines the right queue, notifies WAS that a worker process is needed. WAS will start up the worker process just in time. What we do now, if you have over 100 sites on IIS, we don't set up queues in advance for everything. We set up a single queue that listens to all requests coming in on port 80. When a request arrives, only then do we configure the queue so that HTTP sys knows how to route it. And then from there, the request processing happens as normal. I want to show a demonstration of dynamic site activation. Through the demonstrations today, I have 2 demonstration machines set up. This one with the blue background, this is Windows Server 2012 R2 running IIS 8.5. I have a second machine with a green background. This is running Windows Server 2012 with IIS 8.0, which we released late last year. I've pre-configured these machines with a number of sites. So we can see on this machine, I have the default website, plus down the left side of the page, I have 10 sites. I want to show you, you can actually query HTTP sys to see the bindings that I was talking about. And the way you do that is with a command called netsh http show service state. It scrolled a whole bunch of information by. What I really want you to see is that we've already set up a queue, even though I've not sent any requests to the server. We've already set up a queue for each of the 11 sites on the machine. Let's take a look and see how IIS 8.5 is different. So in this machine, I have the same default website plus 10 additional sites. When I look here, though, if you look at the queues, you don't see all of the 10 queues listed. We just have the one queue set up listening to all requests on port 80. When I make a request to the machine, this is the new IIS 8.5 home screen, home page. Make a few requests. We'll run that same command again. And now what you see is we've registered default app pool. So what we can do now is you can have an IIS machine set up with a very, very large number of sites. We won't use any resources for those sites until they're actually needed. Let me show you what that looks like and what the difference is between IIS 8 and 8.5. I'm just going to stop IIS completely. And also stop our UI. I have some application notes.configs pre-set up, so we'll copy one in place here. Okay, what I've done now is I've set up a configuration with 10,000 sites. So on this little virtual machine sitting on my laptop, this virtual machine's got 2 gigabytes of memory. I'm just sitting on my laptop, and we'll see how it does with 10,000 sites. So we want to time this. What we're going to do, I have a PowerShell script called measure and time memory used. What this PowerShell script does, this PowerShell script will issue the command to start IIS, and it'll time how long it takes, and it'll report how much memory was used in that operation. So let's go ahead and let it run. We're starting IIS with 10,000 sites. And we took about a little over 7.5 seconds, and we're consuming almost 339 megabytes of memory for WAS alone to store that. If I were to start the user interface, it would take about the same amount of memory. Let's go see how IIS 8.5 is different. So we'll start this again. It should take a similar amount of time. Took a little less, took 2 seconds. Let me make sure I've got the right application notes.config in place. I've still got the 10 site one. We're correct now. We'll let this start up with 10,000 sites. And we're sitting about just under 6 seconds. We're using 223 megabytes, so that's a substantial chunk less. We're still working on this. I've got, sitting on my desk back in the office, I've got an update to this that will take about 30 megabytes off of that again. And I have one of my developers working on cutting it in about half. And so by the time we ship, I hope to be able to show you a number that's about half that. Now, we can do the same. So again, very small list here. We've not registered any bindings for these. We're not consuming any kernel memory for these. And we're consuming substantially less WAS memory. We'll go back to IS8, and we'll do the netsh. And I'm going to let this is going to scroll for a while. So while this is happening, I'm not going to wait for it. Just make that go away. Now let's see what happens if we go for a truly large number of sites. Try 100,000. We'll go ahead and start IS 8.0, starting up WAS with 100,000 sites. This is going to take a while, so let's do this. We'll come back to IS 8.5. 100,000. Okay, start the same script. We'll let this run. Let's check on the 8.0 machine while we're at it. 8.0 machine hasn't started yet. This is going to run for just a little bit of time. It should take just under a minute to start an IIS machine on a laptop virtual machine with 100,000 sites. Let's go check on 8.5. It's still running as well. I want to go ahead and mention, if we have any questions as we go through this, I love to talk about IIS, so if I say anything that doesn't make sense, or if you have any questions to clarify, feel free to ask right during the presentation, and I'm happy to address that. I'm expecting the 8.5 machine to return here in just a second. Check on the 8.0 machine. That's still chewing away. The other thing I should point out is that my laptop's actually running both of these virtual machines at the same time. Here, we've got IIS 8.5, has come back, took just under a minute. This is on a machine with 100,000 usable sites. We're taking 1.5 gigabytes of WAS memory. Like I said, I hope to cut that in about half by the time we ship. So this is something that's actually very doable. 8.0, let's see what it looks like. 8.0 is going to run for a while longer. I ran this demo late yesterday, and IIS 8 actually never did finish starting. It crashed at some point. It gave up because it didn't have enough memory. So let me go ahead and show one last thing before we move on to the next topic. Go to 8.5. The next question that might come up is, so you've got 100,000 sites on a machine. How in the world would you administer that? We haven't forgotten about that. So let's go and we'll start. So we'll start up INET Manager. INET Manager will come up. Open the site list, and it says, what have you got here for sites? I'm contending a little bit still with that IIS 8.0 machine on the same laptop. So it's going to come back and says, oh, you've got 100,001 sites. I can expand the list, which would take a huge amount of time to expand. What if I don't want to wait for that? I can just go to the Sites menu, come up to the filter, and let's say you want to see site 77,575. There it is. You can open it up. You can go ahead and administer it right now. So even with a huge number of sites on the machine, you can administer each of them the same way that you normally would. And we'll reset, see if the IIS 8 machine ever came back. It did not. So IIS 8.0 wasn't able to start with 100,000 sites in this configuration. And it's not running. So let's go ahead and switch back to the slide deck. I want to talk now I have two computers up here. I'll talk about the next topic. So I can configure a huge number of sites on IIS without taking a large amount of resources. The question now is, how many can I run at the same time? It's not just, it turns out in cloud hosting, it's useful to be able to have 100,000 sites and run a small number of them, because you would set up a server farm, and each server in the farm would be configured identical, so they all knew about 100,000 sites, and your front-end router could just hand traffic off in any direction. But we'd still like to be able to run as many sites as we can. The next feature we have in IIS 8.5 is idle worker process pageout. So I want to talk about isolation considerations. What you could do if you wanted to run a very large number of sites is you could set up a single application pool, and then you could put 100,000 sites in the one app pool. And that works fine. The problem that you have with that is those sites are all sharing the same process, and they can all interfere with each other. We want to be able to isolate them better than that. What we shipped starting with IIS-6 is we had the ability to have a large number of application pools. We discovered we're memory bound, so the limiting resource, if you're going to run a large number of sites at one time, is memory. And so how do we reclaim those resources? In IIS-6 through IIS-8, the way you reclaim those resources is you do what we call idle timeout. So we'll start up a worker process server request, and then if we don't get requests for a period of time, we'll just shut that worker process down. And that works really well. We're able to run a large number of sites. That's functional, and it's what most hosting providers do today. It does bring up an issue, though, and this issue is probably the number one thing we've been working with hosting providers on for the last several years, is something called cold start time. What cold start time is if my server is completely idle, or if my app pool is completely idle, how long does it take me to start that worker process and then fully initialize it? And so we did some analysis on this. We went and talked to a number of customers to figure out what their configurations look like, and then we did analysis to see in our lab what things look like. So we started with a pretty typical setup. We had a load balancer with multiple IIS machines in a cluster. Most hosting service providers we see are using a NAS, and on the NAS they have a shared common configuration that the servers use, and all the content lives on the NAS. They also have multiple clusters talking to the same NAS. So we set up a similar environment. We set up a similar set of applications and tried to drive a similar workload. Some of the boring details. Each server was set up with 4,000 sites with various popular web applications. We assume that there's going to be a continuous set of about 500 sites running. A couple of sites are going to be starting up at any given time. A couple of sites will be shutting down at any given time. And then we also know from talking to customers that the NAS devices are multi-purpose, and they have many things going on at the same time, putting a load on the NAS. To account for that, we took 7 client machines and just started driving file share load on the NAS. And then we ran some tests. This testing was done pretty early on before we really started getting into IIS 8.5. And so we did our testing with IIS 7.5 and IIS 8 to see how those two compared with each other. And what we found with IIS 7.5 was something very interesting. We found that we can start up a site pretty quickly in IIS 7 and 7.5. We're sitting here under 1 second to start it until we get up around 430, 440 sites. And then we start seeing an increase in the amount of time to start a site. And this is just serving a plain HTML page. Turns out that most of that time gets back to the configuration system again. We were very careful with IIS 7 to come up with a very high performance configuration system, but we didn't have the scalability that we need today. In IIS 8, we did a pass-through on the configuration code and rewrote parts of it. And what we see in IIS 8 is that we're able to start a site, typical sites, about 300 milliseconds. And then we eventually get to a steady state where we're starting up between 300 and 400 milliseconds for static files. So that's pretty good. That addressed the issues we had in the configuration, and now we see that we can bring one of those idle sites online very quickly. What happens, though, when you have applications on your server, which everybody does? So we did some testing with PHP. And what we found is that the graphs look very similar, but the floor is different. So what we see on the IIS 7 is our floor is around 4,000 milliseconds, or about 4 seconds, up to about 500 sites, and then we see that same increase due to the configuration. In IIS 8, we see that we've largely addressed the problem with the configuration system. It's a few outlier pieces of data here, but we still see that 4-second floor, and we can't get any faster than that with IIS. And the reason why is because it's not IIS taking that time. So what I want to show you now is how we determine that. We have one of the most common, I've been the lead for performance and security Right now I'm the lead all up for IIS. But for the last 5 years I've been performance and security and servicing. And one of the most common questions I get is, how many sites can I put on the server? And the answer to that question is, it depends. It depends completely on what applications you want to run. And the only real way to find out is to test for yourself. So what I'd like to show today is I'd like to show just a quick step that you can use to kind of test for yourself and see what the time profile looks like starting up a machine. So let's go back to our IIS 8.5 machine. Now we'll leave this running for now. I stopped WASP previously. I have another application host.config. So what I've done now is I put a configuration in place where I've got a bunch of sites running a typical managed app DOS blog. So let's see what that looks like. So let's hit site 1. What I want you to watch as I do this is I want you to watch up on this tab here. At some point you'll see waiting for site 1. And when you see that, that's an indication that we've already connected and we're just waiting for the server to respond to us. So let's hit that and see what happens. So we're connecting, now we're waiting. There's DOSBlog. And so the question is, what happened during that waiting period? Turns out we can instrument that and find out. We can do this with a tool that is available to any of you. I have links near the end of the slide deck. This tool is called the Windows Performance Analyzer. And the way it works is it works with ETW tracing. So let's configure that. I've previously configured Logman, which is a tool that ships with Windows, to recognize the ETW events for IIS, for HTTP/sys, and for ASP.NET. If DOSBlog had chosen to, if the folks who write that app had chosen to, they could have put their own events in there as well and be able to instrument that. Now that I've started the trace, let's hit a different site. Hit site 2. Connecting, waiting, DOSBlog's running. Let's see what that looks like. Windows Performance Analyzer, open up my trace, created an ETL file. Just open that up. Under System Activity, we'll say I've got some trace events. I'll bring those here. Zoom these so we can see them. So these are the trace events that happened when I started up that new site. One of the interesting ones I want to show you, this orange one here is http.sys. And this time here, which is about 159 milliseconds, when we get to this blue one on the top, that's IIS, started the worker process and is starting to process the request. So we're sitting right around 15/100ths of a second before the worker process is ready to go. Then we have this huge chunk of time between here and here. What's this time? This is 1.49 seconds where IIS has handed off the request to ASP.NET, and we're waiting for ASP.NET to answer. And then in this last chunk, you can see during this period of time, we have about a little under 0.6 seconds that was actually used for the application to process the request and send the response. So you can use the same tool to do a more in-depth analysis and figure out exactly what's happening at each step of the way. There's links at the end of the slide deck that shows you where to get it. The takeaway for me is that we spent a huge amount of investment over the last several years looking at how to improve cold start time. What this shows me is that's not the right thing for me to be doing. And the reason why is I can't control anything that happens after here. At this point, IIS has already done its job, and it's just waiting for the application to go. So there must be a better thing we can do. So we took a different approach. We said what we need is a way that we can reclaim that memory, because we're memory bound, without actually terminating the application. Turns out there's a way to do this that we've implemented in IIS 8.5 that we call idle worker process pageout. And the approach here is for each running application, when it goes idle, instead of shutting it down, we just tell it to release any memory it's not using, and we put it to sleep, effectively put it to sleep. It's still ready and able to take a request, and if a request comes in, it'll re-bring in the memory that it needs automatically. But during the time it's not taking requests, it'll consume a very, very small amount of memory. We've implemented this as part of our idle timeout action, and we're calling it suspend. It used to be terminate was the only option here. Give you a little picture of the UI. So idle timeout action used to be terminate was the only thing available, and after 20 minutes by default, we'd shut it down. Now we have an option to suspend it. Let's show you what that actually means on a running server. Let's go back to our IIS 8.0 machine here. And for part of this, we're going to want to be able to watch what the machine's doing. So bring up Task Manager, and we'll look at the memory consumption. If we take a look at Site 1, spinning again, waiting, and we have DOSBlog. So now I've got a bunch of DOSBlog sites on this machine. Let me run another script that I have. It's called Start 100 Sites. It's actually going to start 50 sites, sized appropriately for the virtual machine that I have set up here. And all this is going to do is IIS is running. We're going to sequentially go through and make a request to 50 sites and force them all to fully initialize. If we look at the running processes on the machine right now, we're going to see that we don't have a lot of running processes. There should be one worker process hanging out somewhere. There he is. Site 1, that's the request that I just made. Let's start at 50 of them and watch what happens. So this is actually going to get the machine pretty busy. So what I've noticed running the demos is that the task manager stops talking to me because the machine is so busy starting up these sites. If we look back at details, we should start seeing now, yeah, we're starting to see a bunch of worker processes all starting up, taking, I don't know, somewhere between 10 and there's a 40 megabyte one. Memory's still going. As with the other PowerShell script, this one's going to give us a time at the end and tell us how long it ran. In my testing, it runs about a minute. So if anybody has any questions about what we're seeing, it'd be a good time to do it while we're waiting for these sites to start up. No questions? Okay. So there we go. It took us 54 seconds to start those sites. And what we see is that now the machine is pretty well memory bound. We're using 1.7 currently of that 2 gigabytes of memory that I have. And in our virtual memory, we're sitting at about 4.2 gigabytes. I'm just going to let this run for a little bit. These sites are all configured to time out and terminate after 1 minute. So we're going to let that happen. While that's happening, we'll go back to 8.5. We've already set up DOS blog on this guy. There we go. And I think the script's in a different place. It is. We're going to run through the same exercise here. Bring up the task manager again. Set it to show memory. And let's let it go. So this guy's going to take a little bit of time to start up. Well, it's busy starting all these sites, asking for 50 of these things to compile and run. We'll go back to the first machine. And we'll see now that we're starting to see the memory drop off. And what's happening is these processes are all reaching 1 minute of idle time, and IIS is terminating them. So if we go look at the details, we'll see it seems like they're all gone. I don't see any worker processes running again. So if we wanted to go and hit a DOS blog site, let's do site 3 this time. We're going to wait for a second. Waiting. We paid the startup cost again. Now that it's done, I should be able to refresh it. And now it comes back immediately. So we're not paying the startup cost again. Let's go back to our IS8 machine, or 8.5 machine. 55 seconds. Took about the same amount of time to start up all these sites. And we see memory. Again, we're using about 1.5 gigs, 4.6 gigabytes of the 6 virtual that I have available. If we look in the details, what we're going to see is I have a huge number of sites running here. A lot of them are sitting around 30 megabytes or so. Again, configured to time out after 1 minute. And what we might see is it drop in 2 steps because of the granularity of the timer. Should be coming up any time now. So in the audience, how many people, is there anybody here that's running a hosting service provider? Here, so we do have a few around. This is something that when the preview is available for 2012 R2, we'd love to have you try this and give us feedback on it. Now what we're seeing is the memory drop off. We have done some pilot with a few hosting service providers with very good results in machine utilization. If we go back and look at the details, we'll see that all these sites are still running, but look at the memory consumption now. In this column here, they're now sitting around 1 or 2 megabytes each. They're not consuming a lot of memory. If we go to, let's pick site 3. Comes back again more or less instantly. So we're not paying the startup cost again. Memory's sitting low. Let's run through. Let's just go ahead and start all 200 or all 50 sites again. See how long that takes. So now we're going to go through. We're going to hit all these sites again. Oh, 2.8 seconds. So that's how long it took to bring all of them back in. And so what we've done here is I think we've finally got an opportunity to work around the problem that we see with the cold start time. So now, here's the point where I said we're going to talk about something completely different. So most of the development effort that we had went into the scalability work that I just showed. And it's a little difficult to demo because there's not a lot to see. It all just works in the background to make the server work better. we do get a pretty constant stream of requests for features to IIS. One of the requests that we've been getting for a very, very long time is to be able to customize the logging. And one of the things people want to be able to do is they want to be able to log whatever custom fields that they want. The most common one that we see is for people who either have their own reverse proxy or are taking requests from clients that run proxies. They want to log the X forwarded for header. It seems to me anyway, seems like this would be the easiest feature in the world for us to implement. But people have been asking for it for at least 5 years that I know of, and we haven't been able to deliver it. The question is, why is that? I want to talk a little bit about how development teams work at Microsoft. The current logging design for IIS 8 and earlier is that IIS does not do its own logging. And so if we wanted to add that field to be able to log the X forward for header, we simply can't do it because it's not our code. We have to work with another team, and then that other team has to implement that. And that other team happens to be in a different division of the company. And so it's kind of hard to make that collaboration work on a regular basis. Once we started taking requests for, if we did X forwarded for, then the next header people wanted would come in and we'd have to go through the negotiations again. What we've been looking for is we've been looking for a fundamental design change that lets IIS own producing the log files. And that's something we were able to do in the time between Server 2012 and Server 2012 R2. In the interim, I'm going to call out just a little bit. There's a module called the Advanced Logging Module. And this is an interesting one for me because the IIS team did not write it. It came from another team in Microsoft, but it provides the ability to log some of these custom headers. And so we have a lot of customers using it, but it really wasn't designed to be a general purpose logging tool. And so it's a little bit of a support thing for us. And so we've taken the parts of that that people want, and we're just building it into IIS 8.5. So here's a little bit about the classic design. The client makes a request. These are numbered. It goes through HTTP sys in kernel mode. Worker process handles it. When the worker process sends the response down, it includes some logging information. HTTP sys combines that with the logging information it has, and then HTTP sys writes the log files. Very, very fast, very, very efficient, but not customizable, which has made it hard for us to handle customer demand. We have a more complicated design, which makes things a lot more flexible for us. Now the request comes in from the client, it gets to HTTP sys, and the first part works the same. The worker process handles the request, sends a response. When the worker process sends a response to HTTP sys, it includes the same logging data that it did before, but now HTTP sys doesn't write to the file. HTTP sys publishes an ETW event. We have a new service in IIS called the W3 log service. It listens for those ETW events. And when an event comes in, the log service says, okay, a request got served. Here's the main logging data for it. Now I can go back to that worker process and I can say, give me the extended data. I can coalesce that data together, and the logging service can write the log file. Have some UI shots here. I'm not going to spend a lot of time on these slides because I'm just going to go through a demonstration and show what it actually looks like. I have yet another application host config file. Start this up. So now I should be able to go back to localhost. Make a request. And let's go look at the login directory. Should have a bunch of requests here. And you can see these three requests have, these three lines are the requests that I just made. Now, let's say those went through a proxy. I don't have a proxy server configured here, so I have another tool that we use for testing continuously on the IIS team. And this is a tool, again. You can download this tool. I'll have a link at the end of the slide. You can use it yourself. And what I can do with this tool is I can say I want to simulate a request that came through a proxy by adding a header. Make the request. This is not a browser. It's actually a test tool. So what I get back is the actual HTML the server sent. Force a flush. See a larger log file. We see my request again, but that 123.123.123.123, which is the client's original IP address, doesn't show up here. Let's see if we can change that with the custom logging. So I'm going to log in, and now this looks very similar to what it used to look like. There's some new log event destinations, which I'll talk about in a minute. Right now, what we want to do is select fields. These are the same fields at the top that you're used to seeing in current versions of IIS, but now we have a new custom field section. And let's add a custom field. And we'll just call it x_4. Request header. We've populated the three different types we can do. We can log a request header, we can log a response header, or we can log a server variable. I'll show you why server variables are interesting in a minute. Source. These are some popular headers that are already built into the system. Let's pick a custom one, x-4. OK, OK. Go back to our wfetch. Log a couple, do a couple new ones. Take a look at the logging directory. Let's bounce everything. I have fallen victim to one of the most common issues that we see with our UI. If anybody else has ever done this, let me know I'm not alone. Way up in the corner there is an apply button. So now that I've applied it, let me try it again. Make sure I've got everything running. Make a few more requests. Now we have a new log file. The enhanced logging files have an _x appended to them. This is to distinguish, for two reasons we do this. One is so that you can distinguish them from the HTTP sys log files. The other reason is, as a developer, I think about all kinds of weird things that can happen. If you get into a state where you start switching between the two logging modes, you add custom fields and then delete them, you can get your log entries in weird orders and not the file you expect. And so we separate the files to distinguish them. So we'll bring it up here. Now, what we have, x_4, not logged, back at wfetch. And what we see is that I typed it in correctly. Force a flush. Did I? Apply's been done. All right, so now what we see is we are logging the x-forwarded for header. So this is probably the most common use I expect to see this. Logging request and response headers, though, is not terribly interesting. What if you wanted to have an application that could log any random data at all and have it show up integrated into log files? This is another common request that we get, and there isn't any way to do it today in IIS. What I have running on this machine is I have a module that I wrote that doesn't handle requests, but anytime a request comes in, it creates some server variables. And these server variables just capture some data about the state of the worker process at the time it runs. So let's go ahead and run that. The other thing I want to show you is something that, as a developer, means a lot to me. I don't like having to bounce the service every time I want to flush the log files. So let me show you something we can do here. We have our logging configuration. I'm just going to add a new attribute. Now let's call it log file flush by entry count W3C log. Yeah, thank you. And let's just set it to 1. What this is going to do is this is going to tell the log service to flush after every request. And so every single request will cause a flush of the log file. And we're going to go back to the logging configuration. And we're just going to log some server variables as well. And let's call the first one total requests, server variable. Total requests. My module that I wrote will keep a count of the number of requests that each worker process handles. Process uptime. This one keeps track of how long the worker process has been running. And we'll add a third and final one. Process private bytes. add that one. Hit the apply button. And what we see is I have a typo in my configuration file. And it's going to be right there. Try applying again. I don't know how many of you have seen this before, but IIS has our configuration is schematized. And so if you don't have a handy reference to know what a particular property is and you ever want to find out, you can just load our schema file directly. Again, assuming that I can type it properly. Flushed by entry count. It doesn't have the word log file in it. Hit the apply button again. This time we save the changes successfully. Let's go back to wfetch, make a request, make a few. Gotta wait a few seconds, make another request, and let's go take a look at that log file. Now, if we take a look towards the end of the log file, we see some new data. We see towards the end where it lists the fields. We see total requests, process uptime, and private bytes. And so if we look at each individual log data, we see that's request number 1, uptime 0 seconds, consuming that much memory. We see the time delay, process 5, request 5, had been up 8 seconds. Now you can see that. So you could write a module or you could write an application that creates any arbitrary server variable with whatever data you want. Have your application or module set that up and then configure logging to capture it and all the logins integrated with the rest of the W3 service logging. And lastly, let's go back to the slide deck. This architecture that I described a few minutes ago with the ETW events, it gives us another capability that we haven't had in the past, and that's real-time logging. So we do get customers who want to be able to capture the logging data in real time and process it, and what our guidance has been up till now is, well, it's a better idea to wait for the log files to be written and then parse them in post-processing. That's not necessarily the best answer anymore. It's just a design reminder that shows HTTP/sys is now sending us ETW events. What we can do is we can go to that log service, and in addition to writing log files, we can rethrow our own ETW events that have the log data in them. And so that is in that other section of the UI I said I would mention. Let's go back and take a look at that. So I'll go back to logging. And right now, we're set at the default, which is log file only. We could, if we wanted to, throw ETW events and write the log file. Or let's say you don't need the log file at all. Let's say you just want to handle everything in real time. Send it to a database, do whatever you want to do with it. You can do ETW event only. We'll apply that. Now, when I make requests, it's not going to write it to the log file. It's just going to throw an event. We need someone to listen to the event. In general, we expect that most people will write their own apps to catch and handle the events the way they want. I'm going to show you one that you can use, that you can download from Microsoft today as a general ETW tool. And that is the Microsoft Message Analyzer. And what we can do here is we go to the Capture menu and take a look for providers. Search by IIS. And we have a new provider, Microsoft Windows IIS Logging. And we should be able to start the trace. There it is. Thank you. I'm a developer. I spend all my time looking at code and coding tools. They don't let me out much. And let's go make some requests. And see, now what we see is we see this guy catching the requests. And if we look down in this window here, you can see each of the fields that would normally be there. So there's the client IP address, the site name, to get request, to isstart.htm. So you can just capture and process these ETW events in real time. Hit the stop button. See, they put the start button in the lower right, and then they put the stop button in the upper left. So that's those are kind of the key things that I wanted to show you. In summary, we've done a huge amount with scale up, site scalability. We've removed the configuration as a bottleneck to the number of sites you can put on a box. We've taken steps to make it painless to be able to page out running worker processes, so you can have a very large number of them. We've tested this. I think we've tested with up to 10,000 running processes, and it works great. Made some logging enhancements that customers have been asking for a long time. There are a couple other sessions I'll call your attention to. There's some unfortunate timing. The session on the Windows Azure Pack, which is the self-hosted cloud, is happening right now in a different room. We have Windows Azure websites. That's the other piece of that arc at the beginning, the Microsoft-hosted, Azure-hosted cloud. That talk happened yesterday, but you can go and get download the information from it if you missed it. Related content, tools that I used, WFetch, the Windows Performance Analyzer, and the Message Analyzer. You can go and get them from these URLs if you want to play with them yourself. Some general TechEd resources, probably a slide you've seen before. Please do send out an evaluation. I look pretty closely at those to figure out how to tune talks for the next one, especially if you have specific comments. I look at those really closely. Any questions? Is the information useful? Is the product, are these the kinds of improvements that you want to see to IIS? I guess is my question. Yes? The question is, it's shipping soon when? And the answer to that question will come out sometime today, I think, at a different conference. It will ship with Windows Server 2012 R2. So as soon as that announcement comes out, that's when you'll be able to get it. Any other questions? That's what I have. Thanks for coming in. Please fill out an evaluation. Thanks.